Jó reggelt kívánok, Budapest! So I assume it was more or less correct, so I will carry on with my Duolingo lessons. And by the way, Duolingo is a terrible and great platform at the same time. It's very easy to use, but the lessons that you get there, well, when I was trying to learn Spanish from it, I got phrases like, tu padre es elegante, which translates to, your father is an elegant person. Because this is basically what you need when you go to a stranger on the street and you will start a conversation with it. Tu padre es elegante. So yeah, remember, if there is one thing that I want you to remember from my talk, that would be it. All right, enough of this banter, at least for now. My name is Rafał, and I work as a senior software engineer at Hotjar, where we create tools that can help you better understand your users' behavior and gather feedback from them. Among many things that I enjoy in the product engineering, I especially like data and playing with online experiments, and this is what I'm going to talk about in this session. To explain the concept of online experiments, I will dig into history. So let's move back to the 18th century, when the first A/B test, kind of, was run. Sailing exploded at that time. It was literally the golden age of it. But sailors had to face many challenges, and scurvy was one of them. The concept of vitamins was unknown back then, and the scurvy was leading disease and the cause of deaths of thousands of men. Around 1750, James Lind, a surgeon sailing with the Royal Navy, was trying to figure out how to help his comrades suffering from scurvy. So he ran an experiment. He treated his fellow sailors with different types of acid-like additions. He had a hypothesis that they could purify their bodies from scurvy. The surgeon divided the sick men into 6 groups. The first group received seawater, the second one cider, the third one citruses, the fourth one a paste made out of garlic and mustard, so very creative, the next one barley water, whatever that is, and the last one sulfuric acid solution. So of course the group that received oranges and lemons got better after a few days. It seemed to be a huge success. The surgeon proved that citruses could be an effective cure to a disease that was a cause of death of hundreds of thousands of men over the years. All of that in a kind of clinical trial, or if you prefer, an A/B test. But then, unfortunately, he made a mistake. So the surgeon started serving a semi-boiled concentrated juice. As we know today, the process of boiling destroys vitamin C. So the juice had very little or no effect at all. But Lind didn't retest his findings in another trial, so the cure wasn't known, promoted, or adopted for thousands of years. Apart from this being a cool story to tell at a barbecue party, there are 2 learnings from it. The first one is to not trust your gut feelings and retest your changes. And always base your beliefs on the data if it's available to you. And the second one, when life gives you lemons, don't always make lemonade out of it. I hope that was for a joke, not for drinking the water. All right, what are the online experiments that we know today? Many of you work at companies where the A/B tests are run regularly, perhaps even on a huge scale. You might even have dedicated platforms built in-house for this particular purpose. But even with that in place, there is plenty of room for making mistakes. And I will confess, I have made a bunch of them on the way. So the learnings and results were quite rough. So today I'd like to share with you a bunch of things that I wish I knew earlier or understood better. But first, let's do an alignment for those who might not be familiar with the concept of A/B testing yet. Modern A/B testing means having 2 versions of application shipped to your users at the same time and checking which one is performing better. So let's say that we have our user base. We have changes that we want to validate and test. one version of the app that doesn't include the changes, and the other one that has these changes. And we assign our users to these versions randomly and representatively. In a typical A/B test, we measure a certain metric that we believe should be influenced by our change. It could be, for example, an engagement, click-through rate, or completion rate. So what we want to do is to have a scientific level of certainty that our change has an impact on the metric and check which of the version is performing better. So Dan quoted Peter Drucker yesterday. You cannot improve on if you don't measure. And we want to understand which one is performing better, just like James Lind did in his experiment. And by the way, A/B tests aren't meant only for purely business stuff. You can also prove that accessibility changes and performance changes also influence the business metrics. And if you can prove that, you can get more allies if you want to convince your stakeholders, and this is at least how it has worked for me. All right, the other theme of online experiments is the canary releases that I will be also mentioning during my talk. They also rely on presenting a different version of the application to a percentage of users. It could be either a complete version or a part of it that is hidden behind a feature flag. Usually it's done to test how users will react to your changes, gather feedback, test infrastructure, or simply the chance of introducing major bugs to everyone. To give you a better picture of what it can look like, this is how Facebook has been releasing their changes for years. So initially, they do a release to internal users. Then this is the C1 level, and then to 2% of their user base, and then finally to everyone. So at any point of this gradual rollout, it can be stopped if anything is on fire. In some cases, I will be mixing the term of canary releases along with the A/B tests under the single term of online experiments. So, these are well-established and known practices that contribute to correct decision-making and reducing the risk. But yet, some mistakes are easy to make, and even if you have great tools in your hands. Mainly because math isn't always easy, and there is plenty of situations that can surprise you, especially if you are unaware of what could go wrong. So, I will ask you this question. How many of you can safely say that you can truly understand the meaning of following sentences? So these are example sentences that you can find in tools that are supposed to help you with running online experiments. And as we dive into this topic, we can literally crash into an iceberg. There is even more of terms like this. And yes, we have excellent tools to help us with such things. But it's worth understanding the foundations in order to determine if we can trust those tools and how to use them properly. So, to make it a little bit simpler, I'll use an example. Let's imagine that I have a food truck with pizza. Currently, on average, 10% of people stopping by decide to buy my pizza. But I have a very controversial idea. I have a hypothesis that adding pineapple will attract more customers. So the gut feeling tells me that serving pizza with pineapple will increase the percentage of buyers to 12%. So in my example, the version of normal pizza, let's say, is the control version, and the pizza with pineapple is a variant. So let's go through a few terms that are going to be useful for us. First of all, when we create an experiment, we have two types of hypotheses, and out of which only one can be true. The first one is null hypothesis. It roughly states that there is no difference between the variant and the control version in terms of the metric that we measure. So to make it a little bit simpler, let's use our pizza example. It roughly says that adding pineapple to my pizza doesn't influence the number of buyers. Or shortly speaking, that my change doesn't influence the metric. The second one is alternative one. So it says that our change has a direct impact on the metric that we measure. In my pizza example, that would be adding pineapple to my pizza has impact on the number of buyers. Or, shortly speaking, the change does influence the metric. And pineapple is a perfect pizza topping, and that's proved by numbers. So what are the errors that we can make in accepting a wrong hypothesis? There are types. The first one is the type 1 error. It means that we are accepting the alternative hypothesis when the null hypothesis is correct, and the type 2 error is the opposite, when we accept the null hypothesis when the alternative hypothesis is correct. Without digging into too many details, those errors can happen on a higher chance when we jump to conclusions too early by not running our test long enough, and when we have float data, and more on it in a moment. Last but not least, we also have two more important parameters that define our test's quality. The first one is the confidence. You can think of confidence as of confidence that if my variant wins, it would be also true for the entire population. So let's get back to our example. If my test shows that adding pineapple works, it's also true, it's the chance that it will be true for everyone stopping by. We can also define it as the chance that type 1 error won't happen, and we usually define it to around 95%. The last one, so bear with me please, is the statistical power. It roughly says that when I detect my change has no impact on the number of buyers, it would be also true for the entire population. So in my example, if my test shows that adding pineapple doesn't matter, it's the chance that will be true for everyone stopping by. And it's also defined as a chance that type 2 error won't happen, usually set to around 80%. All right, I know it could have been a lot, especially in the morning on the second day of the conference, and especially with such controversial topic as pineapple and pizzas. So I hope I haven't offended anyone. By the way, I asked organizers to have this kind of experiment during the lunch, but they didn't agree. So they are taking much better care of you than I would, so I think that's worth clapping. By the way, the pineapple on pizza is just for purely scientific reasons, you know. All right, we know the basics. So what are the common pitfalls that people face in online experiments? Let's look at it chronologically. Assuming we have a hypothesis and metrics defined, we must determine the sample size. So it will be the number of users that will be assigned to both the control and the variant version of our experiment. It's important for us to acquire meaningful results, and this is exactly why we need that. We don't want to accept a false hypothesis because of not running the test long enough. So we cannot just start our test without defining how many users are needed for the test. Instead, we need to calculate the sample size up front. And you will find many calculators on the internet for that purpose, but they will differ. Some of them will let you define more parameters up front, for example, the test quality parameters that I've mentioned before. If you are looking for a decent calculator, there is a link to one. Slides are going to be linked on Twitter. And I confess, my first experiments were a complete disaster. They didn't include this step, and well, this was one of their problems. And yeah, when I was just starting with experiments, I simply started them, ran calculations on the way, whether I had a winner. And well, this is where we get to another problem, which is the picking problem. As we run A/B tests, we often want to check the results. We have fancy dashboards in our tools. So we might often see that our metrics are showing a difference between the versions of our A/B tests. So we open an online calculator, enter our data, and well, we learn there's a winner. But this is one of the worst things that we can do. So let's get back to my pizza example. Imagine that out of first 10 people stopping by, 5 decided to buy my pizza. So does it mean that my variant is so successful? Or was I just lucky and I observed an early extremum? So the very same thing could happen, just in another scale in our experiments. And from a statistical standpoint, the chance for it is huge. So we cannot end our tests too early. What we can do? So first of all, we need to reach required sample size, at least in most of the cases. This is why the first step, the one that I've mentioned before, is important. Secondly, if you want to use our real-time data, we can use sequential testing. Sequential testing defines certain criteria under which we can end our test safely. But most of the time, we will need to stick to required sample size. If you would like to learn more on sequential testing, there is a fantastic article on this topic. Last, we can also trust engines that do some kind of magic that enhance traditional frequentist statistics to shorten the experiment's duration. For example, VWO switched more to Bayesian approach, and I will be talking about it in a moment. And there are 2 links to papers for both Optimizely and VWO, which are the leading platforms for A/B testing. All right, let's play a game. Let's guesstimate. So, for my pizza example, what do you think? What would the required number of people for my pizza example for both the control and the variant version, so a sum of people? So just to remind, the current percentage of buyers is 10%. The expected percentage of buyers would be increasing to 12% with my changes. And the quality of test is defined as 95% for confidence and 80% for power. To make it a little bit simpler, there are 4 possible answers to this question. So, who thinks it's A? Please raise your hand. Who thinks it's B? And C? And D? So, I think A was the least popular, and then D. And the D is the correct answer. So, this is just to give you a picture of how many users we need in our experiments in order to acquire meaningful results. And this is where we get to another problem. I know, a lot of problems. Insufficient traffic. So one of the most common problems in online experiments is having insufficient data to conduct our tests quickly. And time is of the essence. First of all, dragging experiments in time means that we are risking being influenced by other factors. Secondly, our industry is highly competitive, so we need to simply move fast and run tests quickly. So how can we make them shorter with having the knowledge of the issues that I've mentioned before? Well, in traditional frequentist statistics, we can simply go for lower confidence and power and accept more risk. So depending on the type of test we are running, if we are okay with accepting more risk for the sake of shortening the duration, this is the simplest way to go. The second idea is to consider one-sided tests. One-sided tests are basically the types of tests that give you an answer whether there is a statistically significant change only in one direction of your metric. So, for example, if we run tests and we are willing to accept the variant only if it wins, that would be a way to go. Also, last but not least, we can experiment with Bayesian approach. The Bayesian approach roughly gives us an answer about the chance that one version outperforms the other. So, to make it a little bit simpler, let's get back to my favorite example of pizza with pineapple. Pizza with pineapple has 71% of probability for attracting more buyers than regular pizza, where the 71% is just changing over the time as we run the experiment, and hopefully with the time we get to a higher percentage as we get more people involved and more confidence. So over the last, this could be more digestible information for people who have no statistical background, and also just the fact that we get this information updated with every piece of data flowing in might be more practical for us, but well, there are some problems with it. We've seen an increasing adoption of this approach, for example, by VWO, the engine that I've mentioned before, but there are some errors that are still present in this approach. So yes, there are some parts of this model that are hidden, and if you are willing to give it a try, please to dig a little bit further before you jump on it. So my recommendation, if this is an option, try to combine both Bayesian and frequentist approaches and make decisions being aware of issues of both. So I've mentioned that we shouldn't end our tests too early, at least most of the time. But what if something is off? We need to learn why. So in most of the cases, we won't learn about the why from the numbers that we measure. And I'm not Simon Sinek, so I'm not going to tell you start with why, but understanding what's going on in your product is crucial to running successful tests. And this is where additional tools might come handy. So first of all, error logging and technical metrics could give us hints that something is wrong with our test setup or simply the variant. And last but not least, we can also use behavioral analytics and watch session recordings, heat maps, ask questions in surveys to users about their experience. So one of the examples that I like getting back to is the rollout of the 3D Secure in the platform that I was working on a while ago. So basically, for those who are unfamiliar with the concept of 3D Secure, it requires you to authorize your payment with additional text code from a text message, for example. So we expected that this kind of change would influence the metrics, but we wanted to understand it better. Initially, we've observed a drastic drop, but because of having the setup of analytics, we seen that the metric were dropping. That raised some additional questions, so we watched a lot of recordings to understand the behavior, and in the end, we fixed those issues, restarted the experiment, and the drop at the end wasn't that significant. So I mentioned that we've modified variance. What should we do in such case? Well, any change in variance means that we are influencing the distribution of the metric. So we cannot continue experiment despite making any modifications. From the point when we make modifications, it's basically another experiment. So we cannot just glue together two pieces of data, at least not easily, that rely on different variables. Therefore, whenever you modify variance, remember to restart the test and try to have as stable surroundings as possible. There are two issues that I wanted to mention more. So, interference. We might forget that our customers can be connected across the versions of the app that we ship. These connections can lead to unexpected results. One of the great examples of that situation was described by LinkedIn. They were basically experimenting with notifications. A control group was the group that wasn't receiving additional notification. The variant had some additional notifications. So what they observed was that not only those who received those notifications were showing an increasing engagement, but also those who were contacted afterwards by that group. Also those who were included in the control group. So we had blurred data, and this change affected not only the variant, but also the control group. So there was no clear way how to run the calculations in order to determine if we had a winner or how it impacted the metrics. So to solve this issue, they created clusters of users based on their networks. And it was allowing them to isolate users between the versions of the applications. So remember, whenever you have a risk of interference, so the connection between the variant and control version, which could lead to a flood data, try to isolate them to avoid the networking effect. And the last one, sample ratio mismatch. Sometimes you might observe that your samples differ from what you had expected. So let's say that I wanted to split my traffic 50% to 50%, but the observed split at the end of the experiment is 46% to 54%. Should I worry about this fact? Well, the answer is yes. Ignoring it could be ignoring also the fact or the hint of issues with our experiment, with the setup of it or gathering the data. So we need to calculate whether this difference is statistically significant, and surprise, we have calculators for it. So yes, whenever you see that kind of a difference, it's also important to run these calculations and perhaps if this is a problem, fix the issue and restart the experiment. All right, enough of these issues. And the last topic that I wanted to talk about in this session is the privacy and ethics of our online experiments. And it's perhaps the most important one in my session. So A/B test can be treated as a way of manipulation, or at least manipulating the content. I will refer to an example from a couple of years ago where a famous social network experimented with their feed. So in that experiment, they were showing either more positive or negative posts to users, and it turned out that this kind of change also influences their mood. The difference wasn't that high, but still noticeable. So let's just think about it. Experimenting with mood in the world where depression statistics are skyrocketing. This is a huge risk. Over the years, we had also other scandals with other companies, for example, playing with a false perception of safety. We are, as engineers, responsible for what we do at our work. And we are not tools without free will, but yet we are a privileged group of people who most likely understands these topics much better than most of the society. So the least we could do is to question and care about what types of experiments we make, keep making people aware, and fight for the transparency. One way to tackle this issue could be to create legislations that enforce mod transparency and would make you require a consent from users if you wanted to include them in experiment. And yes, I know this could be very controversial and you might be skeptical about legislations, because we could end up with yet another popover to go through, or an extra line in a cookie banner. But there are types of legislations that at least partially do their work. A good example of it could be accessibility laws. According to companies specializing in accessibility, this is by far the primary reason why companies have started caring about this topic. There is a project in the US Senate in the early stages that is called the Digital Act, which stands for Deceptive Experiences to Online Users Reduction. The TLDR part of the part referring to experiments is including a user in experiment would require their consent. So to sum it up, running experiments in a reality where we have revenue-driven world will always be the case, and we need to stay mindful of these issues. There is a bunch of links that I wanted to share with you, especially the first one, which contains validated ideas for experiments that are much more in-depth than just switch your CTA color. And this is where I wanted to wish you many successful and ethical experiments created in a transparent way. Just like Adrian mentioned yesterday, remember that it's not boss or company that's on the other hand, on the other side, but real human beings. Thank you. That's all from me.